Hey everybody, welcome back to our sorting algorithm series. Today we're going to be analyzing bubble sort. So bubble sort is an algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. This algorithm does not work well for large data sets since its average and worst case time complexity are very high. The sorting happens through multiple passes. After the first pass, the maximum element gets placed at the end of the array, which is the correct position that it should be in. Same way after the second iteration, the second largest element goes to the second last position. And we continue to do this process until we pass through the entire array and there was no elements that were swapped. So diving into this example here, we have this array that I have predefined, and the key thing here is this boolean named swapped. So we set it to false at the start of every iteration. That's because once we go through one by one through the entire array and we didn't swap anything, then swap would be false, and at the end of that iteration we know that the array is sorted because we didn't change anything at all. So let's dive into this. So first things first, we start at the beginning at 7. We compare 7 to 1. Is 7 larger than 1? Yes. So we're going to set swapped equal to true here, and then we're going to swap 1 and 7. So 1 gets placed at the front, 7 gets its position. And then we're going to change our indicator. So now we're looking at 7. Compare 7 and 3. Yes, 7 is larger than 3, so we switch these. 7, 3. Swapped is already set to true here, so we technically in the code you override it, but it's going to be the same thing. You're setting it to true every time, but it's just keep it there for this purpose. Then we go here. 7 compare it with 2. Is 7 greater than 2? Yes, so we swap these elements. 7 and 2. Swapped is still equal to true. And then we have our indicator here. So now we're comparing 7 and 5. 7 is greater than 5, so we swap these two. Swapped is still equal to true. So we go here. We compare 7 to 4. 7 greater than 4? Yes, so we swap these two. Swapped is still equal to true. And then we're right here. So now we have a number that's after our current index that is not greater than 7. So we compare these two. Since 9 is larger than 7, we stop here. We end the loop, this iteration right here. And at the end of this loop, we see that swapped is true, meaning that we did swap elements, so we have to go back again and check everything once again. So we're going to start at the beginning again. From that last iteration, 9 does nothing because 9 is greater than 7, and we compared these two. So those don't swap at all. Swapped gets set again to false, meaning we're doing a new iteration, so we want to check again at the start after we pass through that anything was swapped here. If there was one thing that was swapped, then we continue again from the beginning. So we're starting here at this 1 index. 1 is less than 3, so we do nothing here. Swapped is still set to false because we didn't change anything. Then we're here. We compare 3 and 2. 2 is less than 3, so we're going to swap these. And now we set swapped equal to true. So now we move our index. We're at 3. 3 is less than 5. So we're going to not do anything. We're going to move our index again. 5 is greater than 4. So we're going to swap these. And swapped is still equal to true because we changed already that first time. And then we compare 5 with 7. 7 is greater, so we do nothing. We go up here. We compare 7 with 9. 9 is greater than 7, so we do nothing here. So now we're at the end of the loop, and we need to check, did we swap anything? Yes, we did. So we're going to do it the whole pass through again. So now we set swapped equal to false, meaning we're going to restart an iteration. So now we're at 1. Is 1 greater than 2? No. So then we're looking at 2. We do nothing from that first one, and then we go to 2. 2 is less than 3. We do nothing. Now we're here. Is 3 less than 4? Yes, we do nothing. Now we're here. Sorry. Is 4 less than 5? Yes, we do nothing. Now we're here. 5 less than 7? Yes, we do nothing. So technically this array is sorted right now, but in terms of bubble sort, we still don't know that it's sorted because we haven't got to the end without swapping anything. So now we're at 7 right here. And the 7 less than 9? Yes. So we're at the end of the array. And now we check. Is swapped equal to false? That swapped is equal to false, meaning we didn't swap anything, meaning that this entire array is in its sorted form. So that's simple terms for bubble sort. So let's just go dive into the code aspect of it. So here we have a little demo set up. I already set up this array with, I think is the original one that we had sorted on my iPad. And then all we're doing here beforehand is we're just printing everything out before, and then we're gonna call bubble sort, which is the method I created that we'll code right now. And then after we sort this array, we're gonna print the sorting afterwards to the console so we can double check that everything worked fine. So starting with bubble sort, the first thing we want to do is iterate. It's a double for loop, so we're going to iterate through the array with I and j. So let's start with int I equals 0. We want to start at I is, or we want to go through less than the length minus 1, meaning once we're at the back of the array minus 1, we're going to stop because we're going to get an out of bounds error if we continue after that. And then we're going to increment by 1 every time. So now that we're here is where we'll put that boolean, that swapped one that we had previously, to indicate whether we swapped something or not. And at the beginning of the array, like I said, we have it set to false. So now we have the inside loop. We're going to do for int j is equal to 0. We're going to go less than the array dot length, not minus 1, because I is already going length minus 1, so we won't even get there at this point. And then we're going to increment by 1 every time. Okay, so this is a good framework. Let me just add the space here for better readability. So set this to swapped, meaning did we swap or not? So okay, so now we're inside the inner loop. So what we want to do here is we want to first check if we're at the back of the array first. If we are, then we're going to continue. So let's do if j equals array dot length minus 1. No, actually, I don't think we'll get to this minus 1 because, yeah, okay, so since we're not even doing that, we don't even need to add this checker. I feel like we'll see right now if I'm wrong. So if array, or since we're not doing that checker, what we're going to do now is do the actual swapping and checking if something is smaller than the next element. If it is smaller, then we'll swap it and set swapped equal to true. So we're going to check if the current array we're looking at j is greater than the one at j plus 1. So this means if the current index we're looking at is 7 right here, this is j is equal to 0 right here. And we're checking if it's greater than j plus 1, meaning is j plus 1 is this 1. So is 7 greater than 1? In this case it is, so we would perform the swapping right here. So first things we have to do is store that temp, so that way we don't lose that value during the swap for the first swap. We store the temp, which in this case would be that 7, which is our current element we're looking at. And then we set where 7 was at, we set that to whatever is at j plus 1, meaning 1 is going to get placed there. We're going to store this 7, and then we're going to put the 1 right there. So at this point in time, right at this semicolon, at this line of code, this array will look like 1, 1. So the reason we store that temp is so we can put the temp back in. And that's key because otherwise you'll lose some elements after you do it during the swapping. So we'll set j plus 1 equal to the temp. And the key here is to make sure you set swapped equal to true. Otherwise, your algorithm will end right here if you don't set that. Oh, sorry, set this to true. In the case that this was your only swap and you didn't set it to true, then you would end the whole algorithm right here, and your list would not be sorted as you expected. Anyway, that's pretty much the gist of it. Once we're outside, let me see, outside the double loop, no, outside the inner loop, here we're going to do the check. If we did not swap, then we're going to break. And that's because, let's say we went through this whole loop, the inside loop once, nothing was swapped. So now we're here inside of this loop, this for loop. Still, once we went through one time, this whole time, nothing was swapped, then we can break out of this loop, meaning the list is sorted, the array is sorted. So if no two elements were swapped by this point, then we know the array is finished, is sorted, sorry. I think this is it actually. This is it's very simple to write, but like I said in the previous demo, the complexity is very bad because you're gonna go through this. If this is in the worst case scenario, let's say this array is flipped, meaning we're gonna have to swap every single thing every single time, then that's gonna be your O(n) squared iteration, your complexity, sorry. So let's run this. I think this is it. Yeah, we're going through. Let's try this out. Let's see what we get. So we should get 1, 2, 3, 4, 5, 7, 9 after we run this. Index 7 out of bounds for length of 7. Okay, I think this was the checker that we didn't check at first. Okay. Let's do one thing. Let's continue if we get to the end. So what I was originally doing was checking the length of -1, meaning we're checking this j plus 1, but the j plus 1 at this point is higher than the length. So we were at this indice and we're doing j plus 1, but there's nothing over here. We're already at the back, so we should add a checker here. So if we're at the array times length -1, meaning if we're here at the back -1, sorry, if we're here at the back -1, then we'll continue. So we don't throw those. Oh, sorry, length -1 is actually going to be at the 9, not the 4. So if we're at the, this is because the index start with 0, 1, 2. So for example, this is 1, 2, 3, 4, 5, 6. This array is size 7, but the indices will be from 1 to 6. So if we're at indice 6, which is array length -1, then we don't do anything. So let's continue this. Let's run. Let's clear this. Okay, so before you can see here we printed that out, and then after we get 1, 2, 3, 4, 5, 7, 9. Yeah, so everything worked good. Let's just put in another dummy values so we can check. Let's say 12, 19, 33, 44, 9999, and then let's do 3. I don't know. Let's try this. Let's clear this console. And then we'll run it. Okay, so we get 3, 12, 19. Yep, everything looks good. So this will conclude bubble sort. Like I said, the complexity is very bad for bubble sort, but it's easy to teach as a beginner. And it's easy to understand as a beginner once you start getting more hands-on work with it. All right, thanks for watching.